everyone, welcome back to 10th standard maths class. In the previous video we have finished first 3 questions from the last activity. Okay, now let's move on to next problem. 3 more question is there to finish this section. So let's do question number 4. Here is your question. Question is, calculate radius of incircle of right triangle. Okay, radius of incircle of a right triangle with the perpendicular sides as 5 cm and 12 cm. Okay, perpendicular sides are given. We have to find the radius of the incircle. Okay, incircle radius. We know equation is what? General equation. Radius equal to a by s. This is a general equation for all the triangle. We can apply this equation to find the in radius of a triangle. Okay, in radius equation is a by s. But here it is right triangle. Okay, right triangle means one more equation is there. Okay, that is only for right triangle. Equation is r equal to sum of perpendicular sides. Okay, sum of perpendicular sides, then minus h means hypotenuse. Okay, minus hypotenuse whole divided by 2. This is the equation to find in radius of a right triangle. Okay, only for right triangle. So sum of perpendicular sides mean sum of perpendicular sides given as 5 and 12. 5 and 12 are the perpendicular sides. So it's a sum means base plus altitude. So 5 plus 12 minus h by 2. So here hypotenuse we need to find. So let's find hypotenuse first. Hypotenuse equation by Pythagoras theorem, it is root of base square plus altitude square. Okay, hypotenuse equation base square plus altitude, that you know. So 5 square plus 12 square, base and altitude, that is root of 25 plus 144, that is root of 169. That means root 169 is 13 centimeter. Okay, so 13 centimeter is the hypotenuse of this right triangle. So instead of h we can write as 13. So 5 plus 12, that is 17. 17 minus 13 by 2, that is 17 minus 13 is 4. 4 by 2. So 2 centimeter. Okay, so 2 centimeter is the in radius of right triangle with the perpendicular sides 5 centimeter and 12 centimeter. Okay, equation is sum of perpendicular sides minus hypotenuse by 2. General equation is this one. So area divided by semi perimeter. This is a general equation to find in radius. This is for right triangle. Okay, so this is fourth one's answer. Next one is question number 5. Question is, prove that if hypotenuse of a right triangle is h, okay, and in radius is r, then area equal to r into h plus r. This is we need to prove. Area equal to r into h plus r. Area of a right triangle with a hypotenuse as h. Here figure is not given. We have to draw the rough figure. So this is a rough figure of a right triangle with the incircle. Okay, incircle also here, and hypotenuse is given as h. Hypotenuse here CB is the hypotenuse. Let's mark it as h. And radius is what? In radius is r given. So let's mark here O to D is radius and O to E also what? Radius. Okay, now here you can see radius. Okay, radius and these two tangents make a square. Okay, 90 degree. This make a square because radius and tangent is always perpendicular. So this is perpendicular, this is perpendicular, means these two are what? Tangent. So r square, all the sides equal. So this is r means here also r, then here also r. Okay, these two sides are also r. Now here base and altitude is not given. Base and altitude. In order to find the area we need base and altitude. Equation is what? Area. Area equation is half bh. Okay, so here base is not given, height also not given. So let's consider the base, the complete base as a and altitude as b. Okay, total a, b, then hypotenuse h. So total a to b is small letter a. Out of that a to d is small letter r. Then remaining will be what? A minus r. Okay, remaining one a minus r. Now here a to c total is b. Out of that a to e is small letter r. Then remaining e to c will be what? total minus this portion. So B minus R C. Okay. Now B to D and B to F are tangents. We know tangents from outside point to the circle is equal. So this is A minus R mean this is also A minus R. Now C to E and C to F also equal tangent. So B minus R here means here also B minus R. Okay, so these are the measurements we have to consider. Now here hypotenuse is already given h. Okay, so h equal to what? H equal to sum of these two measurements, that is A minus R plus B minus R. Okay, that is equal to what? A and B we can add, minus R and minus R means minus 2R. So A plus B minus 2R. Okay, now let's take this minus 2R to this side. This we need in the further step. That's why I am doing this earlier. So minus 2R come to this side, it will be H plus 2R. Okay, minus 2R come to this side, H plus 2R equal to, here remaining is A plus B. Okay, so A plus B, sum of two perpendicular side, answer is H plus 2R. Keep it aside. Next is area. Area we need to find. What is the equation? Area. Area equation we know it is half BH. Before that we have radius. In radius we have, okay, in radius equation is what? For a right triangle, in radius equation is sum of perpendicular sides minus hypotenuse by 2. So let's write that equation first. So here perpendicular sides are A and B. So A plus B minus hypotenuse whole divided by 2. Okay, so this is the in radius equation for a right triangle. Now what is the general equation? Radius, in radius general equation. General equation R equal to A by S, area by semi perimeter. Okay, this is a general equation. Now according to this equation, what will be area of this triangle? Area of triangle, keep area here, take this S to this side, that is A equal to R into S. Okay, area will be equal to what? In radius into semi perimeter. Okay, in order to get this area we are considering the general equation. From this we won't get the equation, that's why we directly consider in radius equation of right triangle. Okay, so according to the general equation of in radius, radius equal to area by semi perimeter. Therefore area equal to in radius into semi perimeter, R into S. Okay, so semi perimeter means what? Semi perimeter, S means what? Sum of all the three sides divided by 2. Okay, sum of perimeter divided by 2. So perimeter means A plus B plus H, perpendicular sides AB then H, whole divided by 2. Up to this we got. Now let's apply all this in this equation, that is area equal to R into S in radius. For this right triangle, in radius is what? A plus B minus H by 2, that we already found. A plus B plus, sorry, B minus H by 2 into semi perimeter. Semi perimeter also we have, that is A plus B plus H by 2. Okay, now A plus B, instead of this A plus B we can write H plus 2R, because we have to prove in terms of R and H. Okay, we need H, we don't want A and B, that's why we are going to remove this. So instead of A plus B we can write H plus 2R. Okay, from here we can write that. So it is H plus 2R minus H whole divided by 2 into A plus B, again same, H plus 2R plus H whole divided by 2. Okay, now here this H and H we can cancel, H and minus H. So remaining is what? 2R by 2 into, next is what? H plus H, that is 2H. So 2R plus 2H we have. Let's take that 2 outside. So remaining will be R plus H whole divided by 2. Okay, 2R plus 2H, that's why 2 outside. Now these two we can cancel, these two we can cancel. Now what remain? R into R plus H. So we got area equal to r into r plus h. H plus r and r plus h both are same. So we got the proof. So this is area equal to r into r plus h with the hypotenuse as h and in radius and as r of a right triangle. Area will be this one, in radius into in radius plus hypotenuse. Okay, without doing all these we can directly write the answer, area of a right triangle. If we know in radius, okay, suppose in radius is 2 centimeter and hypotenuse is 13 centimeter, we can directly write the area. How? 2 into 2 plus 13. Okay, directly we can write. So this is fifth one's answer. Next is question number 6. Prove that radius of incircle of an equilateral triangle is half the radius of circumcircle. Okay, and here figure is not given. This is a rough figure. ABC. Here triangle ABC is an equilateral triangle and incircle is given and we have circumcircle. Both are given. Okay, we have to prove radius of incircle is equal to half of radius of circumcircle. So let's consider in radius. Okay, in radius, that means inside one. In radius, let's consider a small letter r, and circumradius. Okay, circumradius let's consider as capital letter R. That means we need to prove r equal to half of capital letter R, that is r by 2. In radius is equal to circumradius half. Okay, this is what we need to prove. So here let's consider the triangle OAD. Triangle OAD let's consider. As it is an equilateral triangle, we know one angle is 60 degree. So this angle will be what? 30 degree. So here OD is the in radius, that is small letter r. You can see OA from the center O to A. This is the circumradius, that is our what? Capital letter R. So R and R we have. So which one we can consider here? Sine angle we can consider. So sine 30 equal to opposite side by hypotenuse. Opposite side is OD by hypotenuse is OA. Sine 30 value is 1 by 2 equal to OD, that is small letter r in radius, divided by OA, that is capital letter R. Now in order to get this, let's arrange the equation. That is, take this capital letter R to this side. So it will be r by 2 equal to small letter r. That is the same as this one. Okay, so for an equilateral triangle in radius, okay, in circles radius will be equal to what? Half the circumradius. Okay, because the center is the same. For an equilateral triangle, center of incircle and center of circumcircle both will be equal. That's why we can consider like this. Okay, so this is the proof of sixth one. So chapter over. Hope you understood. Thank you. See you in the next video with the new chapter.